Welcome back, Generals, to another Let's Fix Generals 0 Hour to make the best game ever. Good. I just realized that we can also remove this comment here. So I'm back at the height map camera change refactor. I think it's this change. Yeah, it's this change. Let me make a fix up for this guy. So that's just that. Good. So, oh boy, it has been a while I touched this. I took some notes here, I think, on what to do next. So remove lights iterator from functions. I think we did that, right? Yeah, this one. So that should be done. And then what did we do? We did some simplifications. He did some refactoring. Yeah. Here. The next one was investigate needful update and clean up this mess. Oh boy. Well, that needs some brain. Ooh. Yeah, let's take a look at it. Does need full update. Oh boy. True if lighting changed and we need to update all instead of what moved. We need to update all instead of what moved. Lighting change. We need to update all. Yeah. Need full update. Tell lights to update next time through. Need full update. Init height data. This init height data. But this is a virtual call. What is it passing? A map and then null? It's passing null for true. Null, so false. Update extra pass tiles. Oh boy. Oh. What is this here? Okay, that seems wrong. This one should be false, right? Init height data false. Yeah, like here, false. Yeah. Oh boy. So I will set false here. Okay, we're trying to clean up this mess. Oh, need full update. Oh boy. Oh. Yeah. Need full update. Init height data. Need full update true. Okay, let's set that to remove that. Okay, what do we have here? So here it explicitly says a file. Now we do this. What do we have here? Update center. Need full update false. Okay, let's remove that. Yeah, okay, what else do we have? Need full update. So update center, need full update block. So then it would update the whole block, but we already. Okay, let's look at all the places first that call true. Let's set this to true. So reacquire resources. That one would do it. Why? Tell lights to update next time. Reallocates all W3D assets after a reset. Okay, let's just remove it. Yeah. Okay, here we have another. Init hide data. Okay, well, that's just that function. So here we just remove that as well. That should be fine. And then here we have static lighting change. Cause a terrain to get updated with new lighting. Static lighting change. But this one doesn't really change, right? We already figured that static light is not actually used, right? So update lighting. Static lighting change. Static lighting changed. Yeah, let's remove this. Okay. Okay, so then updating. Okay, that would be the next. We don't look at updating for now. Okay, and then not need full update. We remove that. And then, yeah. Need full update. And we set that to false. Oh, then we have also this one here. Does need full update. Let's see what happens on this core. Not much. Update. Oh. Oh, that's also weird. Huh. Huh. Does need full update. Update terrain. Huh. Well, that is strange. So this one we don't care right now. In high data we don't care. Then it must be only this one. Static lighting changed really. And oversized terrain, I guess. But that also calls init height data already. Which also set it. Yeah. Oh boy. So I suspect that we probably need to look into calls to this guy here. Static lighting change. Let's take a look at this. Okay, that gets called at multiple places. Oh. 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 Yeah. X for load. Oof. Update the display height map. The problem I have with this logic is it's so complicated. Like, you first have this call, which sets a flag, which then signals W3D view to call the update center function, which then goes into the branch for doing the full update, which then returns the update center, and then it does some full update, and then I don't know what happens afterwards, but it's some weird, complicated flow of logic, which is really putting us on the edge, right? Yeah. This one is also supposed to be false. This too. False. Update extra pastimes. Yeah. Static lighting changed. Okay, so now we totally eliminated this full update. Now the question is, what will be the consequence of this? Probably bugging. Probably have some bugs now. Well, let's take a look. So I think for starters we can merge this here. Fix wrong arguments to init height data. Wrong passed arguments. Okay. Okay, so let's install this thing. And then take a look. Yeah, so now the question is, what do we need to test? Oof, I don't know. A penis salt. So we have this dozer here. We have somehow a frame lock. Good, so we take this guy here and we build here our power plant. Oh, now we have no terrain deformation. Aha. Okay, so there's already the first bug. And remember, we already had that. Alright. Okay, so somehow the full update is necessary, but not for the reason we thought it was. Well, here we have another one. Do full updates. Still needed here. Update center. I remember this one where we were able to remove this, right? Here it does a return. We can remove that. Okay, looks like we still need it for this shit here. It's also weird setting it to false right afterwards. Oh, this code is so weird. Oh man. Oh man. Okay, so this updating thing, what does this do? Updating, update center, updating. Oh boy, no need to center. What is this doing? Oh my gosh. Okay, this could be very complicated. This code is so overly complicated. Absolute spaghetti. Absolute spaghetti. Update block. Yeah. Yeah. I don't know what the strategy here is. Oh no. Oh, now it is updated. Look. Uh-huh. So if we tap out and back in, then it updates. No? Okay, I don't know what made this update. Maybe the scrolling. Ah, the scrolling probably. Uh-huh. Ah. That could be. I mean, it'll restart. Yeah. I suspect we need to do an... Yeah, we need to do some update here when we modify the terrain. The question is what? Update block. Update block. Uh-huh. Update block. What is update block? Update block. What is this function doing? The vertex coordinates and texture coordinates as well as static lighting are updated. Aha. The vertex coordinates and texture coordinates. Aha. Aha. Oh. Vertex coordinates and texture coordinates. Updates a block of vertices. Aha. Uh-huh. Aha. Mm-hmm. So, oops. So what if we move this update block into world height map? World height map, CPP. Where's this function? Set raw height, this one, right? So here we do this. So maybe we need to call up update block base. Can we do that? Update block. Well, I'm not sure. It's not a static function. Well, we need to call this guy. Right. So update block. Aha. Aha. So, oops. Ah, update block. So after all these, and then we pass in a region. Region low x. What does it take? X0, Y0. So low x, low y, and then high, high, high. Okay, and then we we pass this. Okay, so with every... Oh, this could be quite costly, right? Yeah. Maybe it's fine. Okay, so basically it would update it on demand when the height is modified. Pre-compute textile norma. Okay, so maybe this would now correctly update the block when we update the terrain. But this would mean that we would also need to do it at many other locations. Yeah, the problem is we would then need to find all the different places where we can modify the terrain and then update the block, which is essentially what I did before already, just with this flag, right? Oh, that doesn't work. Oh, never mind. Oh, that's too bad. Let's put a breakpoint here. It does call. X, Y, X, Y. Maybe it's the wrong coordinates. Update block. Min X. Draw origin. Adjust range into the current drawn map range. What? MX -1. 0. Do partial update. Map cell coordinates relative to the entire map. Aha. Aha. Oof. 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 Do partial update. Okay, so okay, it doesn't say what coordinates these are, but it seems that these are in the draw update block. To me, it looks like it can only update the block when it is within the draw boundaries. Where we look at. It can't update it outside our view bounds. Ugh. But we could call update VB directly, maybe. Yeah. Maybe. Oh. Oh boy. Oh boy. Update VB. Oh. Run copy. Okay, so to me it looks like we need to call update VB. Oh boy. Oh. Step through each vertex buffer that needs updating. Okay, I start to understand the motivation here. So it really only updates, it only really updated anything on the viewable terrain when it was in the draw area. And outside nothing is updated. Yeah. Which works fine as long as the drawable area is small. Right? As soon as you make it larger, it becomes more costly. Yeah. Updates a block of vertices. Yeah. I see. Okay, this could be tricky. Update block. This is quite a bit difficult here. Do partial update. Takes a partial range. Yeah. But the range is expected to be within the draw bounds here. Yeah. It's also weird here. Lazy allocation. That's stupid here. Okay, I'm not really sure. So what we did so far is we made all this update block logic cheaper by providing all the pre-computed stuff for updating the vertex buffer. But the goal is to update the vertex buffer. But that is still happening. We still have a full update. Well, we removed it now, but that's the status quo. There still was the full update, which would update the vertex buffer over the full drawable region, which was expensive when the drawable region is very large. But still, it's also expensive when we scroll around the map, right? Especially if we do it fast. Well, if we, like, I suspect what will be expensive if we click on the map, it will have to recompute the whole thing, right? Like this. So, like looking at this place and then looking here means it needs to recompute the vertex buffer for this whole region, if I'm not mistaken. Yeah, because it will have to do update block on all these. Yeah. 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 Now the question is, how do we deal with this? This doesn't work for some reason. Update block. X0. Low X. Low Y. High X, high Y. This didn't work because of the coordinates, right? Yeah. Yeah. So, how do we mitigate this? That block. Oh, this is not easy here. Yeah. Pre-compute. Yeah, we would need to pre-compute update block. Yeah, I'm not sure what the strategy here was by the original developer to update the vertex buffer every time a tile comes into view. Like, why was this a motivation? I wonder if there was a good reason for this. It means that like every time you revisit a tile, it needs to be recomputed, right? So you see a tile, it's computed. You go away from the tile, it's out of view, and then you get it back into view, and it needs to be recomputed from scratch. And then it did all these different steps, like getting the normals and like the other things that we already pre-computed here. The UV data it computed, the normals and the ambient light always was computed for every tile that came into view again and again. If you just scroll around, it recomputes everything. I suspect the thinking here was that only if we visit a tile, then we should do some computation for it. Otherwise, we don't care about it or something like that. But the vertex buffer, that one always exists anyway, right? Update VB, that always exists. Yeah. There's a lock here, lock vertex buffer. Yeah. Get pre-computed UV data. wonder if this stuff here is even necessary. Not sure. Because if this is the only place where we need this, then we could also just like pre-compute this guy, the whole vertex buffer, and just keep that in memory. But it is in memory already anyway. Yeah. Yeah. Do the pre-computed light. Update VP. Update a rectangular block of the given vertex buffer. Data is expected to be an array same dimension as current height map, mapped into this VB. Okay, so to me it looks like we need to pre-compute the VB. Yeah. And then we update the VB. Yeah, I mean, yeah, origin. Update VB. Find all. Update VB. Update VB. X-min, Y-min. Origin X, origin Y. Origin X, origin Y, X-min, Y-min, X-max, Y-max. Now we times. Origin. Why does it call update VB so often? That's surprising. Okay, that's quite a bit complicated. Let me put a breakpoint here. For 4. Huh. 1532. Okay, I don't quite understand what's going on here. Update block parameters have inside out rectangle. Top right edge, top edge. Top edge. 129. Update center. It's much more efficient to update a couple of columns, one frame, and then a couple of rows. So if we aren't jumping to a new view and have done X recently, return. Oh boy. Okay, so he did already do some optimizations here regarding update blocks. Question is all this very efficient? I don't know. Delta X, delta Y. Delta X, delta Y. Blah, blah, blah. Aha. Maybe that's why we saw, maybe that's why we see the flickering on pitching, because it time slices the update here. Yeah. Maybe. Yeah. It time slices the update by one frame. It's not very nice. Yeah. Oh. Okay, the question is, how can we set draw origin update block? Oh boy. It's also strange that here it checks for larger than limit, and then here it checks for larger equal limit. That also doesn't look right. And here it checks just larger limits. Right? Yeah. So that already looks wrong. Something is wrong here. I suspect that this is meant to be removed here. Just larger center limit. Yeah. Oh boy. So it looks like this update block shit here was meant to optimize this stuff, but it's not particularly cheap, especially when we do a full update. Then it's expensive. Full update. Oh boy. Question is, how can we optimize this? Update block. Update VB. Yeah, it is a bit strange that it expects that the vertex buffer can only be updated. Well, only this one. Update block. The vertex buffer only. I suspect the vertex buffer only contains the area that we're currently looking at. It doesn't contain anything else. That's why it needs to recompute all of this. Yeah. Yeah. Yeah, I don't know if it would be legal to no, just to take like a portion of the vertex buffer, but then I think that wouldn't work. Like, let's say you have the vertex buffer is a whole map area, XY, everything, but then you can't just take a portion of that, because like it's in this continuous array, right? This VB, so I don't know how this would be laid out in memory. So it's probably all right that the vertex buffer is just this fixed size subset of the whole terrain, and like every time we go to a new edge, it updates the whole thing. Why does it update the whole thing? Well, it has to, right? It has to move. Does it do a mem move? How do we... How do we... I don't understand, like... if we would shift the the vertices around in this subset. But then it would require mem moving all sorts of memory, but it's not doing that. So how does that work? I don't know. Okay, that's a mystery. Yeah. This vertex buffer that we are passing in there, let's take a look at this guy. Update block, mmap, here. There we go. Vertex buffer tiles. 4 plus I. Good. Let's look at. We have a vertex buffer tiles and backup. Let's take a look at this guy. I think we already looked at this, if I'm not mistaken. Does it contain everything or not? Where do we allocate it? Here. Here we allocate it. So 4 times 4 vertex 16 times that backup tiles times num vertex. It does take. Okay, but it does take XY, which is the size. Yeah. Need to allocate. Yeah, so this one is 129. Yeah, so the vertex buffer is sized by these dimensions here. This 129, which we will upscale, which grows when we do oversize. Yeah, so the vertex buffer is small. Yeah, it's not holding everything. Yeah, good. Okay, I understand. We have a P data and a PVB. What is the difference between these guys? Backup tiles, num vertex. Oof. Okay, I don't know what that is. Okay, I don't know why we have 4 and 4 here. 4 times 4. I don't know. Num vertex. Okay, I don't know how this comes to be, but there probably is some math behind this. Tiles. Backup. Vertex format. Vertex buffer. To correct row column or vertex buffers. PVB. P data. Update VB for light. Oh boy. Okay, this one we need to study. Yeah. So the PVB is being locked here, and then we can write into it. Can we? PVB here, VV hardware. Yeah. Where's it being written? Here. Here's it is written VB hardware plus offset. Hardware data VBase. Okay, I don't understand this shit here. VBase is data. Why do we have a PVB and a data pointer? We have been building the vertex buffer in the memory location. Now copy the set of vertices into the hardware buffer. We don't copy the whole vertex buffer because we often update only a couple of rows and it's a lot faster to just copy the ones that change. Okay, so it looks like we have like a vertex buffer, copy, and data. Yeah. Okay, so PVB is the one that it's in the GPU, in the VRAM, video RAM, and this one is in RAM. This guy, that's my understanding of this. And here we can, so this would mean that here we could keep everything, and here we just keep a subset or something like that. Is that already the case or not? Let me see. Well, but then we wouldn't reallocate this guy, right? Requested height map different from old one. So to me it looks like that this backup here, is also just a subset of the whole terrain. Maybe this backup here would need to be the whole thing. I don't know. Is it already 16 times that non-vertex? 16. Non-vertex buffer time 16. I don't know. Is this ever different? Can this be different from this? Yeah, so here this is a direct, yeah, okay, so this is the hardware buffer, yeah. It's a DirectX resource, okay. But this one is here. X, Y, Z, diffuse. Okay, so this one already stores all sorts of data. Good. I see. So can we maybe make this the full size of it? If we could make this guy the full size, let me put a breakpoint in here. Let's see how this goes here. Oh man, this is quite a bit more complicated than I remembered. Yeah, but the more understanding we get, the more we can improve here, right? Yeah, but my hunch is that then we need to make this guy cover the whole terrain. But then we first need to understand how it is currently. So this one is 16 and this. Okay, good. So I would like to understand. If we go to DEFCON map here, and then we lower the pitch to force an oversize, then what do we have? Aha, now we have 64 here, not 16. 64. 8, 8. So that's twice. NumVB tiles. Yeah, because this has grown here. I don't know, something has grown here. This one, 257, there we go. 257, so that has grown now to 88, so it's 4 times as large and the edge is 2 times as large. Yeah, and so that will allocate a bigger buffer here. Same. Yeah, yeah, that's a bit shitty. But then I still don't understand how. Backup. Yeah, so let's see how this guy is used. So the backup is used here. Vertex. P data. Backup. It's extremely complicated. In-memory copy of the vertex buffer data for quick update of dynamic lighting. That's not so quick though. Collection of smaller vertex buffers that make up one height map. Collection. Height data. Yeah. This will not be easy here. So I think it would be great if we could make this vertex buffer backup, if this could span the entire height map. And then we would just pick tiles from there to copy into this guy. But I'm not yet sure how that will work. Tile 64. Let's back up. Vertex buffer backup. Oof. Oh boy. I mean, it would be cool if we could get rid of a bunch of intermediate things here. So in here we have added a bunch of new data sets, right? These guys, which in the end, all these guys here, they only feed into Where is it? Into these guys, into this backup. It feeds into this. Right, so maybe we can remove all these pre-computations again and just put everything in this guy. But then this would need to cover the whole map and not just a portion of it. But then I don't know how easy it will be to, yeah, to get that to work. Basically, we don't want to update just where we look, but we only want to update where something actually changes. I think that's a big difference. Because if we just update where we look, then we need to update the whole terrain that covers everything that's in our view. But if we only need to update what actually touched and has been changed, then that should be much cheaper, unless there's like a lot of stuff that changes on the map all the time. Right? Yeah. Yeah. Full update. Yeah. Right now it's a bit of like something in between. The vertex buffer is still updated just in the view, but we do pre-compute the whole map, but only also on terrain height editing. We don't update it on Xfer, on safe load. Oh boy, I'm not so sure anymore if this is the right course of action here. Yeah. The EA optimization was okay for a small view, but yeah, it was expensive when updating a large area, terrain area. Oh boy, how do we deal with this? I'm not sure. Oh. Fuck. Okay, let's see where this is used. So, on-frame updates, it's used in there. Okay, what is this? So that is called every frame. Yeah, on-frame updates. But this one, will it reach down here every time? Update VB for light. Mm-hmm. Hmm. Yeah. Yeah, I don't know what we do here. So right now they are in sync, these guys here. Right, as you can see here, they have the same size, but this one here is a bit different. Non-vertex. Non-vertex. Yeah. Updates a block of vertices. I mean, if we scroll it, to me it sounds like we need to update everything at some point. If we scroll around. Let me put a breakpoint here again. So if we now scroll, then goes in here, min x map y map. Data j. So what is j? J is 2. This one is 4. 2 times 4 times that. I is 0. J 4. Okay, whatever. 0. Vertex buffer tile length. So it needs to. So it needs to update a full tile. And that tile. 0. J2. Why is J2? No idea. Must have hit some continua here. this VP. Okay, I don't fully understand yet how this works here with the tiling. Yeah. Yeah. Pre-computed UV data. So this one is only used here, right? Yeah. And this one is only used here. No, it's also used here. And here. And here. Which are all disabled. Except for this one. But I think this one was never called. Oh, this is really quite some challenge here. Yeah. It's probably easier to just leave it as is for now, but then we'd have to always do the full update. Yeah. Yeah. Full update. Yeah. Yeah, I think I have opened here a rabbit hole. Pandora's box. Oh. Yeah. Yeah. Full update. How do we deal with this? I don't know. X, Y, X, quick height. I just realized here we can simplify this code a bit more. Update VB. Yeah, we can add it to this change here. So here, like this one is the same as this here. So we can just move this guy down here and this guy down here. And this guy down here and there. Like this. Makes it a bit easier to look at. Yeah, at least something. We can, oops. Then we can make a fix up for this here. This. Yeah. 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 I mean, we do have these different coordinates, right? So these are the ones with the draw origin. These coordinates together with this here. Jesus. Okay. Yeah. Skip to correct row and vertex buffer. I'm not sure about this guy here. What? But this guy, it does have the same size as our hardware buffer. So, but I don't understand these coordinates here. It's quite a bit complicated. But it works correctly, so it must be correct. But yeah, it's not particularly easy. VB. And VB is then copied into this VB hardware plus offset. Vertices minus base. Vertices minus base. Update only a couple of rows. Yeah. So we only copy 4 at a time here. Yeah. Update a rectangular block of the given vertex buffer. Data is expected to be an array same dimension as the current height map, mapped into this VB. Yeah. Yeah. Oh, I'm not sure how we proceed from here. This is quite a bit of a complication, I would say. Good. I think I will take a break here. It's quite a bit complicated. Yeah. Good. Maybe take a look at what has updated here. Good. I think I will just merge it and then it builds, so I guess it's good. Yeah. Okay. Good. Yeah, this one is really difficult. It's just so much stuff here in this height map. Man. Oh, it's so annoying. It's so annoying. Update VB. Yeah. Yeah. Good. I will end it here. I wish you a great day or night. Until next time. Goodbye.